What is a primary key? What is a row? What is a table? What is an entity? What is a foreign key? How composite key works and how table and relationship work. In the last video, we discussed about a lot of different SQL concepts, but in this video, we are going to discuss mostly around table and relationship. Now, I'm going to explain you how table and its relationship works and what are the important key things in the tables to understand how SQL begins. So you have to stay till the video, till the end of the video to understand how table and its relationship work. We are going to discuss deeper into the concept of the table, entities, rows, and how primary key, composite key, foreign key works in the table. So let's start. So here we have a table that is named as users table. I want to keep it simple, so I don't want to make it very complex. So I just had one users table with three different rows. Three different rows means these are three different data. This table has one ID. There are three different columns. The header section of the table is called columns, and there are three different columns called ID, name, and email. These three columns define the metadata, the structure of the table. Now here's the primary key. The thing with the primary key is it is going to be unique. Primary key is always unique in a table, and this have to be cleared in the beginning of the creation of the table. So we have declared primary key as ID, and you can see that these are very unique. They cannot be duplicated, they cannot be left empty, and you have to define some value for the primary key. Mostly we choose the industry. A common pattern of the industry is to store an integer value to the table so that it can be unique and it can be used as an auto increment property so that they can never match the value and they will always be unique to the table. The second thing is the name, in which we are storing the name of the users, and the third is the email. We are storing the email of the users. Now this is called an entity. A table stores one type of entity, so this table is defined for only one type of data. That means we can only store users data into this table. We are not going to store any other information other than user. So this is what a table is. Key, column, a few column. We can add as many column as we want, and a few metadata to the table. And there are, like you can see, these are represented at different data. That different data is called rows. Each rows represent one single record. Just like you are an Amazon customer, you must be having your user in the Amazon database. That means your one user is defined as a row in the Amazon users table. Now next thing we are going to discuss is primary key. You must be thinking, like, when we declare the primary key, why it is unique and what's the importance of that primary key. So let me help you understand that the primary key holds a very unique property of being a unique type on the table, in which your primary key is only associated with your only user. Now here you can see there is a user table which has like three different primary key, three different values in the primary key, and it defined uniquely, and it is associated with John, Sarah, and Mike, and they all have like three different unique key, and they have their data stored into the user table, and it defined uniquely each row in a table. It cannot repeat, it cannot be left. Uniquely identifies each row. It cannot be null. That means it cannot be empty. Null means empty. Null means empty. And must remain stable. Stable means you cannot just go ahead and change it. A primary key should not be mutable. It should be immutable always. Immutable means, I'm going to write it here. Immutable, it means a value which cannot be changed. A value which cannot be changed. Okay, which cannot change. That is immutable. And the good primary key. The primary key idea is like we should have one primary key always. This is a good concept. If you are thinking of making any other column as a primary key, that's, I would say, is a very bad idea. You should not be declaring any key as a primary key. Primary key should be a unique associated property to the table. For example, if you take email as a primary key, it can be changed, it can be updated. There are many things, so you should not be declaring any other key as a primary key. And email can be changed, ID should not. Yes, so ID is going to be very unique. So this is what a primary key is about. If you have any doubt, you can ask me in the comment section. The next thing is how you should design a table. There are two different things. Like you should always focus on how to design it better, but there are a few things that you have to keep in mind to avoid designing a bad table. So first we will see that there is an orders table. Orders table has multiple different orders. It has an order ID. Order ID is a primary key. I'm writing PK. PK means primary key. So it has a very unique tables, and name on the order tables is duplicated. If you see, John has two orders, so it has two rows. It has three rows. It has four rows. Sarah has one order, so it has only one row. And now we have a different order amount here. Now there's no problem with the order amount, but the problem is the data of the user is being duplicated in the orders table every time. This is clear indication of a bad design. You should not be duplicating the same data every time on a column, on a table, and that is a very bad practice. So duplicating user data is very bad, and it's really hard to update. Just imagine if you are a user, just as myself, I am Tariq Shamim, I am a user in Amazon, and I made a few orders. So if I made a few orders, that means a lot of orders have been created. Let's say 4 orders have been created. Now if I want to change my email, or maybe if I want to change my address, Amazon now have to update and reflect the same address on every order. Like they have to change my email here, on this row, and on this row. There's a high chances that bad data can be updated. There's a high chances of it, since we are making a lot of changes to the orders table. So that is a indication of a bad design, and it is really hard to update every single row after and change in the user's data. Now this inconsistent value makes it very unreliable, so we should not be practicing this one. This is a very bad concept. The good thing is, the good design is, you can associate a user with the order. So instead of replicating or instead of repeating the same data in every order, you can design a different table which actually references the user ID instead of referencing the actual user data. You are referencing the user ID. Since user ID is unique, that means it is going to be only one in the table, and it is not going to be repeated. It is going to be very unique, and this one means that one user is a user with ID 1 is associated with this order. You are not replicating it. Now if I have to update my data, Amazon can update it directly into this users table, and since this ID is being referenced in the orders table, it will always reflect the data which actually exists on the users table. So this is how we use, and this user ID, whenever we mention a user ID, is called a foreign key. That means this user ID is coming from a different table which is outside of the current orders table. This is an orders table. This user ID belongs to user table. That means this key is a foreign key, since it does not have any existence in the current table, but this key can be used against other table to find out the data. That means it's a foreign key. Now the good designs concept is the good thing about using foreign key is less duplication. Less duplication means that it's really rare to have a duplicate data now, since we are only referencing the ID column, and easier updates, of course, since you have only one column, so you have to update only one column per user. Now better consistency means you don't have to replicate the same data all over the places in the order table that consists user data. So this is a difference between a good design of a table and a bad design of a table. Now the third thing which we are discussing about is the foreign key. Foreign key is a really important concept in SQL. Foreign key means a key that does not exist in the actual table and it references the other table. References means it is being used from the other table. It has the value that does not have any kind of existence in the current table, but it can be used against other tables to query the data. For example, here's the users table and it has a primary key. It has some primary keys, and here's the orders table. In the orders table, if you see, we are using user ID. The user ID, if we start to use the user ID, that means this user ID does not exist in the current table. In the orders table, it does not exist. Users ID does not exist. Okay, it does not exist, but it exists in the users table. That means it is associated with a table which is outside of the orders table. That means it is a foreign key. As the word suggests, foreign. Foreign means it is coming from outside. It does not have any kind of reference. It does not have any kind of existence in the current order table, and it is referencing the primary key. That means it's a unique key outside of the orders table. So when we references there any kind of unique key outside of the current table, then it is called as a foreign key. Now the orders, if you see closely, you can see that the orders table referencing the user ID here, it references user ID. That means it's a foreign key. Now the valid example of a foreign key is a user ID equals to 1. That means the user ID 1 is a valid case because a user ID with one value exists in the table. But for example, if you start to store invalid values, it will not allow you to store those invalid values if they don't exist in the foreign table. That means if you are trying to store some order with a user ID 999, it does not exist in this table. It does not exist in the users table. That means it's an incorrect order and it will not allow you to store the data. So it is going to be very reliable and very safe to use as a foreign key, since it will not allow any data which does not have any existence in the users table. So the foreign key connects table and protect the data integrity. Data integrity is really important in the database concept, and it is all about like having a safe and reliable data into this storage. If you have any doubt about the foreign key, you can ask me in the comment section. I'll answer there. Foreign key, we are going to discuss about the relationship between the tables. So we are going to discuss one-to-one relationship. That means that how we are going to associate one table with multiple tables. So you can see there's a user table, there's a user profile table. That means if you have a user table, that means you have your user information on, let's say, Amazon, and you have more information of yourself like address and other stuff like payment details and other credit card information. It can be stored into another table, but they need to be well connected so that Amazon does not need to find out like every table separately for your particular user. That means we are going to connect one table with another one. It is called one-to-one relationship, in which we are going to use a foreign key as a user ID. Now this user ID is a foreign key and it stores information about the user table, and we are going to declare this foreign key as a unique key. That means one user profile table, this cannot have a duplicate data. This cannot have more than one row of this particular user table. So it can only have one user profile information, only one row related to the table, only one row related to this user table, and it cannot have duplicated rows regarding it. This is called one-to-one relationship. And now if we discuss about the one-to-many relationship, that means users table, there's a user table as you can see, and there's an orders table. You can, when you create an account on Amazon, you can have only one user that belongs to yourself, but you can order multiple items on Amazon that can have multiple different orders over the time period. So one user table will be associated with orders that can have multiple orders, and this multiple order will be associated using the user ID. The user ID means that this table is going to be connected with this foreign key. User ID is foreign key on the many side. This is a many side. This is a many side, and this is a one side. As already you can see in the picture, this is one side, this is many side. And this one-to-many relationship means this one user can have multiple orders, but not the other way around. Now this is called one-to-many relationship. Now let's come to the join section. By the way, I have created a very detailed explanation about the joins. You can check out this video, and this video contains almost all the information about the joins and how there are different kind of join, how you can join multiple tables. There are cross join, inner join, outer join, full join, left outer join. All kind of joins are well explained in this video. You can check it out. I'm going to give you a very high level description about this joins and how we can use that in the relationship. Is when you have multiple orders, let's say you have like users and you have the related orders, but now I want to summarize that how many users, who are the users which actually did order. Now I want a combined result. I want a one common result in which it combines both information related to user and their orders. So I am using join. Join means I'm going to use join on this select username. I'm going to select username and the order name from the users table and joining the orders table, and on the parameter user ID join and user ID. So this is a primary key and this is a foreign key. A primary key and a foreign key. So order table is currently associated with the primary key. Now these tables stay separated, but you can query them to have a combined result. Just like this user John and Sarah, they have multiple orders. John has this order, John has this order, and Sarah has this order. Now we have a combined result from them. This is how we can use join in a relationship between tables. The next thing is the indexed foreign key. So indexing is something, if you don't use index in a database, then it is almost equivalent to using a storage. That does not make any sense actually. But if you use index on a table, then it means that you are going to have a very fast search. Your query will be very performant and the database knows where the actual data exists. So if you take an example of this orders table, I am going to index this user ID on this orders table. This is a sample query to do indexing of a user ID table, and without index what happens is the database does not know where the data is stored into their storage space, and it is going to search line by line, which is a really bad algorithmic search, doing line by line search. The next thing is, if you do use index, then database knows where the data is currently being stored into the table. So it knows the source. It will try to look up the matching records and it will find the orders really quick. There's a different of like 100,000 data. It might be pretty easy to pick them up without indexing because that's very less data. But if you have like millions of data in your table, then it is really important that you use indexes. Otherwise, it does not make any sense to have database. So two things with the indexing of the foreign key. The foreign key enforces integrity. Integrity means the rows which exist in the table always belong to somewhere. There is some source of that rows. For example, if you have orders, it belongs to some users. That means it enforces the integrity of the rows, integrity of the data. And adding the indexes on the foreign key improves the performance of the search results. So if you add the index and keep foreign key, the database is ideal. If you have any question regarding the indexing and foreign key, you can ask me in the comment section. Now, the next thing is what happens if a parent row is deleted. A parent row is something that is a parent table. Taking an example, there are like 3 types of delete operation exist on the SQL: on delete restrict, on delete cascade, on delete set null. These delete category are like a kind of a behavior that we can explicitly set on the tables. It is not important to have them, but you can explicitly set just to keep your data integrity. Now, let's take an example of this users table. This users tables means currently this user table have two orders, Alice and Bob, with their primary key. Now, these two Alice and Bob users have some orders in the orders table. If you delete Alice from this users table, that means it has some associated data in the orders table. What will happen to that data? So if you apply the restrict deletion, that it means that it is not going to delete that user until and unless you remove all those orders data. So it will keep that parent data intact into the table. So it will block the deletion until the child rows exist. So if you delete the child rows, the parent table will be free to delete. That means it has a dependency. Now the next thing is cascading. Cascading means implementing a rippling effect. A ripple effect means if you do something on table 1, it will cascade, it will ripple back to the table 2. It will have some adverse effect on the table 2 as well. Now what happens is when you delete a users table, it will also delete all of it related information on the related table. All the information on the related table means that it is going to delete all the data on the orders table of related users. So there are related users, and if you delete Alice, it will also delete the ID 101 and ID 102 from the orders table since they are related to the users 1. So it will delete dependent rows automatically. Third is on delete set null. It means if it is like loosely coupled data, it is not strictly restricted. It means that if you delete Alice, it will let you delete and it will set all those data empty. Now this data lost their integrity. That means it does not belong to anywhere. You will just know that there was some order placed in the past, but there is no user associated with that data. So this is the third option. Probably nobody is going to use that, but there is a feature that you can have. So you need to choose your delete behavior carefully when you start working with the SQL. The next thing is about the common mistake. We make a lot of mistakes as an industry expert. Many people still make mistakes. It's pretty common, it's not rare, but you need to understand some basics of the database so that you can avoid those basic mistakes. Now, there are 5 common mistakes which I'm going to explain you about. A lot of people stores almost everything on a single table, on a single entity. That means if you have users, you're going to store all of the user information into the single table. That is a very bad practice. You need to separate all those entities, just like you have user information on a table, other table is store user address information, other table stores user payment information, the billing information. Those are all different tables that can be associated with one single foreign key or some sort of keys. So storing everything on a single table is a bad idea. Now repeating user data across multiple tables. Now we have been duplicating the data on the orders table one by one. That's not a good idea. You should be always using references in the table and should not duplicate data on different entities. That's a very bad practice and it loses data integrity. Missing primary keys. Missing primary key is not a common one, not a common mistake. It's pretty rare, but if you have any table without primary key, I would recommend you to add primary key as soon as you can, because it loses all the identifies rows, the uniqueness of the table, the relationship and everything. You should have primary key on every single table. The fourth thing is foreign key columns type using different data types. So a lot of people make foreign key, that's a good practice, but imagine somebody using foreign key as an integer on the users table, but they are declaring orders and declaring a user ID as a string or text or a varchar. Varchar means commonly a text. So that's a very bad practice. You cannot just change the data type of the related foreign keys. You should be always using the same mesh column types on the related table. And no index on frequently queried foreign index is really bad. You should not be using foreign key without indexing. You should always index your foreign keys. You should always use indexing on the table. Indexing is one of the best practice of the SQL. So these are the 5 common mistakes which I don't want you to make in future. Let's summarize what we learned. We learned about tables and relationship, in which we learned about storing one kind of data on a single table. Should not be storing a lot of data in a single table. Primary key, each row identifies its uniqueness. So primary key identifies its primary key property. Foreign key means a different table, a referenced table is using some foreign key which identifies the source of those keys. So relationship means how you're going to connect multiple different tables using foreign keys, how you're going to handle one-on-one, one-to-many and many-to-many relationship. If you have any question regarding relationship, these are very important. You can ask me in the comment section. I will be happy to answer that. And the next and the last thing is the joins and how you can use joins in the table. Joins is one of the most important topics in SQL. So you need to understand joins, how they actually work. I have a very brief video of joins. You can click on the link and you can understand how joins works. You will be able to understand how joins actually work. So understanding joins is really important because this is one of the most important things in the SQL. So these are the concept of the SQL tables and relationship. I'm going to cover a lot more in the SQL. So please subscribe to my channel and like this video so that I know that you want to learn. And if you have any question in your mind, you can just ask me in the comment section. And for future videos, just keep subscribe and click on the bell icon if you want. So yeah, thank you for watching the video. See you in the next video. Have a good day.